Hello all. Today's topic is syntax directed definition, which is also called in short SDD. Let us understand what is exactly SDD. Syntax directed definition is actually a syntax tree computation. In the previous module, you will study only syntax tree construction by using a syntax analyzer, but it is not having any meaning with the just tree. So we need to have some computation over there so that we can find out what is the value of that statement which is being used in the programming language. So that's why you need to have a meaning for that. For that reason we have to do a computation. So SDD helps us to do computation on syntax tree, which is also called as high level specifications, which hides the implementation part. So implementation part is can take care of by SDD, nothing but syntax directed translation. So SDD can also be called as a combination of context free grammar along with a semantic rules is nothing but a SDD. But what is meant by semantic rule is it is nothing but an attribute with rules is called as a semantic rules. A production and semantic rules together is called as a syntax directed definition. So what is meant by an attribute here is, which is of two types. One is synthesized and the other one is inherited attribute. A value which is having its own value, so that's why we have used in short dot, nothing but it is having its own value, or if the value moving in upward direction in the parse tree, then such attributes are called as synthesized attributes. Whereas inherited attribute is nothing but if the value is coming from the parent to the child, or it is coming from the sibling, that is only towards right direction, from left to right, then it is called as inherited attribute. So if you understand these two, these are the main two key points in this whole module. So how exactly the values are moving in the parse tree. So one is synthesized and other one is inherited. Synthesized is nothing but if it is having its own value, or it is value moving towards parent side, upward direction. And inherited is, we all know that the meaning of inheritance, if the value coming from the parent to the child or from the sibling left to right, then it is called as inherited attribute. So we also have other terminologies here apart from attribute, that is annotated parse tree. We already know that what is a parse tree. Parse tree is nothing but a syntax tree only, but when you make some decoration on that, that is called as annotations, which contains the value of the attributes at each node. So that is what an annotated parse tree. Attribute is nothing but a value of these are evaluated by semantic rules. Moving on to different classes of SDD, a syntax directed definition can be classified as S attributed definition and L attributed definitions. When you consider a parse tree and annotation of a parse tree, if all the nodes are having S attributed or synthesized attribute, then it is called as a S attributed definition. Every node having a value as synthesized attribute value is synthesized, then it is S attributed. L attributed is nothing but if the values of every node, each node, either it can be synthesized or inherited. That means combination of synthesized and inherited together in a parse tree is called as a L attributed definitions. So we have an example. Later we can see that example 1 is of type synthesized attribute, and example 2 is of the type L attributed definitions. We will see that later. And we have terminals in the parse tree which has always synthesized attribute. So remember that every terminal of a syntax tree or parse tree are having, it is nothing but a child node of that parse tree, therefore it is always a synthesized attribute. It's having its own value. A non-terminal has synthesized attribute or inherited attribute. A non-terminal is nothing but internal nodes of the tree. They always have either a synthesized attribute or inherited attributes. So we have a simple example here to show that which one is a synthesized attribute inherited attribute, and which is not called as a inherited attribute. Say for example, there is a production like this: A produce B and C. In case we are using here dot B and dot S dot I as values, attribute values. For example, B dot attribute B is assigned to A dot S. That means this value is being moved to, that means child value is moved to parent value. That is one value which is being passed in upward direction. But for computation of B value, in case if B dot inherited is computed with the help of A and C together, that means like this. For the computation of B, I am using A value, parent value, that is allowed, but using a value of C, that is nothing but right to left. Okay, as per this, it is right to left you are using this way. So this is not allowed in the inherited or L attributed definition. But look at the second example here. A, B, C, as per this production A, B, C, we are using A value to C and also B value in C in order to compute C value. This is a valid computation, okay, for L attributed definition or inherited attribute. Hope you understood the meaning, basic meaning of S attributed, L attributed, and which makes use of synthesized attributes and inherited attributes. We also have here evaluation of these semantic rules may generate intermediate codes, some additional functionality of it, may put information into the symbol table. It can also perform the type checking, and it may use error messages also. It may perform some other activities. In fact, they may perform almost any activities. Those are called as semantic rules. You can see that while constructing the semantic rules for some of the examples. Let us start with the first example. As I said earlier, it is an example of synthesized attribute. So this we will discuss in the next class, next video. Thank you.